So you hear the term the cloud, and you probably picture something completely weightless, right? Like your photos and emails just sort of.
Just floating invisibly in the ether, yeah. I mean, it's a very comforting illusion.
It really is. But for this deep dive, we're cutting through today's AI hype, and we're pulling from historical tech archives and university records to, explore the absolute opposite of weightless.
Right, the incredibly physical origins of computing. We're going way back to 1945.
Yeah, back to the ENIAC at the University of Pennsylvania, which was initially built for military artillery and thermonuclear calculations. And this machine was just a 27-ton behemoth.
27 tons. It's almost hard to wrap your head around. And it spanned up to like 1,800 square feet.
Which is bigger than a lot of modern apartments.
Oh, definitely. And it used 17,000 vacuum tubes, drawing 150 kilowatts of power. It ran so incredibly hot that they had to build these massive custom fans.
Right, and they had to house the entire system in a windowless, secure room. So, I mean, by all definitions, this was really the world's first true data center.
Exactly. And for all that heat, all 27 tons of metal, the records say it put out 0.05 MIPS.
Wait, NIPS is millions of instructions per second, right? So that means.
You only handle 50,000 instructions a second.
Yeah, my smart toaster processes more than that. I mean, did the military basically just build a 27-ton pocket calculator?
Well, they kind of did. But you have to remember, before the ENIAC, calculations were purely mechanical. Like you had literal physical gears turning.
Oh, right, of course.
So the vacuum tube changed everything because it had no moving parts. It acted as an electrical switch, using heat to control the flow of electrons in a vacuum.
Yeah.
So switching from physical gears to routing electrons was, the ultimate paradigm shift.
I'm still struggling to visualize the actual workflow here, though. Like, if there's no operating system and no hard drive, how are they actually inputting a command? Are they just going in there with a wrench or something?
Not a wrench, no, but really heavy electrical cables. Because you have to remember, programming wasn't typing code at a keyboard. It meant physically rewiring the entire machine.
Wow.
Yeah, and there were 6 pioneering women who did this incredibly exhaustive work.
So they're operating it almost like one of those massive old telephone switchboards.
Exactly like that. They were literally standing between these 30-ton panels, setting thousands of physical switches, and plugging in these really thick cables.
Just to route electrical pulses from one mathematical operation to the next.
Right. And then for the actual data input, they're feeding it physical IBM punch cards. Which is just wild when you think about the scale.
Yeah, the archives mentioned one single Los Alamos test run required 1 million punch cards. 1 million.
It's mind-boggling. And that's why these women were essentially, physical hackers. They weren't just typing syntax.
They were actually building the circuits.
Yeah, right. They were translating abstract mathematical logic into literal physical electrical paths. They really laid the conceptual groundwork for how software interacts with hardware today.
But you mentioned earlier that those vacuum tubes generated a massive amount of heat. I imagine that heat was sort of the enemy of scale, right? Like, to ever get out of that bunker, they had to solve the temperature problem.
Precisely. And that heat problem leads us directly to the invention of the transistor in the 50s and 60s.
Yeah.
Because transistors replaced vacuum tubes, they ran much cooler, and suddenly
computers could actually shrink.
Exactly, which completely changes the architecture of everything.
Right, because by the 1990s, we basically spent a decade ripping computing out of the mainframe to distribute it across on-premise servers.
Yeah, the classic client-server model. I mean, every business suddenly wanted their own localized processing power right there on site.
But look at the irony there. We started with massive, centralized, power-hungry rooms. Then we decentralized everything into, local network closets.
And now we're back.
We went right back. Because of the dot-com boom and the massive power demands of modern web apps, the cooling and power constraints forced us right back into a centralized mainframe model.
We just rebranded it as hyperscale cloud computing. But yeah, we absolutely circled back to centralization.
Because of the physics of it all.
Right. The physical realities of powering and cooling thousands of servers mean it's just vastly more efficient to pool them together in these massive specialized facilities. The cloud is really just someone else's extremely hot, very loud computer.
That is such a great way to put it. The scale exploded, but the fundamental reality of electrons moving through physical switches hasn't actually changed.
No, it really hasn't.
So every time you check an app, your data is flowing through a lineage that traces directly back to those 1940s vacuum tubes and heavy physical cables.
It's all connected, yeah.
Which leaves us with one final, completely wild thought from the sources to wrap up this deep dive. We went from 27-ton calculators to distributed networks and then back to hyperscale clouds in just 80 years. So what is next?
Well, tech companies are actively developing and testing data centers for outer space right now.
Which is insane. If you think about it, the future of our physical data might not even be on Earth. So next time you look up, just remember, the weightless cloud you rely on might soon, quite literally, be up there in the sky.